Hi, everybody. Back again, still in Chapter 6 on simulation. We've looked at a number of examples so far where vectorization has been really useful and looping has not been needed. We need more examples where looping is your go-to strategy. So I thought we'd pick one from some of our practice exercises. I'm interested in problem number 4 here at the bottom. Let's read out the problem. Abe and Bo engage in a duel. So, they've got those pistols, like in the old days, in the early 1800s in Europe, when college males would engage in these sort of honorable duels. So you can imagine them out in a field somewhere, and they've taken a certain number of paces apart, and now they're facing each other with their little probably inaccurate pistols. And they take turns shooting at each other until one person manages to hit the other, thus winning the duel. Let's say that Abe has a 40% chance of hitting a person with every shot that he takes, whereas Bo has a 60% chance of hitting on each of his shots. Now Abe is therefore the weaker shooter, so Bo very honorably permits Abe to go first. And what we would like to do is estimate Abe's chances of winning a duel under these conditions. So we're going to write a function called duel to estimate this probability. Our directions are that the function should have two parameters. Reps, the number of times it takes that we're going to simulate the duel. We'll set the default to 10,000. And seed, so that's a seed that the user can set, and we would like the default value to be null. So ordinarily one practices the problem, and perhaps you have already, and maybe have a function of your own. But I'll just go ahead down to the solutions, and we want to study this particular function in more detail. So I'm going to head over to RStudio, where I actually have an R script prepared to take a closer look at this thing. Let me pop it up big and make the text a little larger for you. That looks good enough. So, first of all, a bit of review. We're going to make use of the mod operator. You'll recall that the mod operator tells you what's the remainder when you divide one number by another. So like 7 mod 3 would be 1, because 3 goes into 7 twice with a remainder of 1. 8 mod 3 would be 2. 9 mod 3 would be 0, because 3 goes into 9 3 times exactly with no remainder. 29 mod 6 turns out to be 5. How about 7 mod 2? Well, that's going to be 1. 7 goes in, 2 goes into 7 3 times with a remainder of 1. And notice that 7 is an odd number. On the other hand, take the even number 8. The remainder after division by 2 is 0. And that's a general fact about odd and even numbers. The odd numbers are going to leave a remainder of 1 after division by 2, and the even numbers will leave a remainder of 0. So a way to tell programmatically when a number is odd is just to construct a Boolean expression with the double equal sign. So just ask the computer, is 7 mod 2 equal to 1? The answer will be true. 7 is odd. Is 8 mod 2 equal to 1? And the answer is going to be false. So this is an important tool that we'll have in mind for the dual function. You'll see why in a moment. Here's the code for the dual function. I'm going to do a quick overview of it. So notice that there's initially some checking to see if the user provided a seed. If the user did, then we'll set the R's seed to the value provided by the user. Otherwise, we just blow by that command on line 21. And then we're going to do simulation. We're going to play this dual reps times. So we set up a results vector to hold our results. It's going to be a logical vector of trues and falses. It's going to hold true when Abe wins and false when Abe does not. And it needs to be reps long. And then we've got our for loop extending from line 25 all the way down to line 44. One way to tell that it extends that far is to go to that final closing brace, and you'll see that the brace on line 25 up here, where I'm waving my mouse, is slightly shaded in. Or similarly, if you went just after the brace on line 25, you'll see that the brace on 44 is shaded in. You can use that trick that RStudio has to help you figure out when a body of code begins and ends. So what's in between lines 26 through 43 is going to be the actual conduct of the dual once. Our iterator is I. Our index is I. Our iterator is the vector of numbers from 1 to reps. We're going to play this dual reps times, storing the results in Abe wins every time. So a duel itself is a complex procedure because it may take an indeterminate number of shots on the part of each player. So we begin by setting up what we call the state of the duel. Is the duel currently happening? And at the beginning, yes, that is true. What is the current shot number? Since it's the very beginning of the duel, the current shooter is on shot number 1. Now, to process a shot, we have a while loop. And to process the duel, we have a while loop. Now we're going to enter the body of the while loop here only if dueling is true. So at the beginning, we will indeed enter this loop. And when we go into this loop, what we're going to do is process one shot. So we have to figure out who it is that is shooting. So I set up a little logical value, Abe to shoot. What we do is we find out if shot number is an odd number or not. Because if it is an odd number, we know that Abe is to shoot. He begins the duel, so he's going to be shooting at shot 1, then at shot 3, then at shot 5, and so on. He'll shoot odd number times. So Abe to shoot tells us whether or not Abe is shooting. Now, we have to find the hit probability. If Abe is to shoot, that's going to be 40%. But if Abe is not to shoot, then Bo is shooting, and that's a 60% chance for Bo to hit Abe. So this little if-else call helps us to figure the hit probability. So hit prob is going to be either 0.4 or 0.6. What we now do is have the shooter, whoever it is, take a shot. So the result of the shot, this name here, is being bound to this function call result where you sample from hit and miss one time, and the probability of a hit is going to be given using the prob parameter. It's going to be given as the first element of this vector here. It's going to be the hit probability. The probability of missing is 1 minus the probability of hitting, and that's the second element of this prob vector. So the result of shot is either going to be a hit or a miss. We now have to figure out whether or not to continue the duel. Has anyone been hit yet? And if so, who was it? So we go into this if statement. If the result of the shot is equal to a hit, we're going to run these next two lines on 39 and 40. So say it was a hit. Well, we need to figure out, does Abe win? If Abe was to shoot and it was a hit, then Abe hit Bo, so Abe wins. The result is true. And we're going to put the true into the ith place of our results vector. But if Abe to shoot was false, then that means Bo was the one shooting and the person who hit Abe. And so Abe wins should be false. That will be put into the ith place. Also, since somebody was hit, we're going to have to turn dueling to false. After that bit of, after the if statement, we also need to update the shot number. The shot number is going to go up by 1. The next person, is going to shoot if indeed there is another pass through the dueling loop. After we get through the while loop, the duel has been completed and the result of the duel has been entered here in line 39 above. And so we do this reps times, and we filled up Abe wins with a bunch of trues and falses. So the last thing we need to do in the function is to add up Abe wins, count how many times he won, and divide by reps, and we've got his probability of winning, or an estimate of it anyway. So that's the idea. I'm going to go ahead and knock this back, and I'll teach this function to the global environment. And I'd like to just run it once in debug mode, so to understand better how it's all working. So run line 51 here, get it in debug mode. And then I'll give it a try. How about duel? And we're just going to set reps equal to 2, so they don't play very long. And I don't really need a random seed. Heck, I'll do it anyway. How about seed equal 50-50? And off we go. So here we are in debug mode. The runtime environment for the function here only knows that reps is 2 and seed is 50-50. Okay, heading down to the browser prompt. We take a step forward, we get into the body of the function. We're going to check to see whether or not seed is null. Let's give it a try. It was not null, so we're going to have to run set.seed, set it to seed. So that's going to happen in a moment. Yes, there we go. So we're now down to the line 6. We're going to set up our logical vector. Remember, reps is 2, so this is going to be a very short logical vector. Here it is in our runtime environment. So initially, when you set up an empty logical vector, it just holds falses. Okay, we're now ready to try out our loop for I in 1 to reps. We enter the loop, and notice that I in our runtime environment is 1. Our index is 1. Okay, we set up the initial state of the duel. Here we go, dueling is true. Aha, that gets into our runtime environment. And here comes shot number is 1 into our runtime environment. We are now at the while loop. So we're going to figure out, are we allowed to enter the loop? Let's give it a go. Because dueling is true, we got to enter the loop. We're going to figure out if Abe is to shoot. Now, we know in advance that Abe is to shoot. This is shot number 1, and he gets to start. But what we're doing is finding out if the shot number is odd. And sure enough, Abe to shoot is true. So now we'll find out the hit probability for the shooter. It should turn out to be 40%. Let's see. Yes, indeed. In our runtime environment, we see that hit prob is 40%. Okay. Now we need to actually have the shooter shoot. And so we sample from hit and miss. There's a 40% chance here of getting the hit. Let's see what happens. Result of shot in our runtime environment was a miss. Okay, so Abe missed. Now, if the result of shot were hit, we would run through the code in this if statement, but I guess we're going to run right by it. Kaboom, we do. We need to set the shot number to be 1 more than it currently is. Shot number shall be bound to the result of shot number plus 1. Let's do it. And sure enough, shot number goes to 2. We are now back outside the while loop, wondering if we can enter into it again. Well, dueling is true, so I imagine we will enter it again. Sure enough. Now, shot number is 2 this time, so I predict that Abe to shoot will turn out to be false. Let's give it a try. Sure enough, Abe to shoot is false. Bo is the one shooting now. He has a 60% chance of hitting. This hit prob should go to the 60%. Let's check it out. It did. See? Okay, now we need to get the result of Bo's shot. This time, there's a 60% chance for hit and a 40% chance for miss. Let's see what happens. Result of shot, another miss. Okay, so we will not go into the body of this if statement. Sure enough, we're just going to update the shot number. Shot number is now at 3. Dueling is still true. So we enter the loop. Abe is to shoot. Sure enough, turns into true. Hit probability goes back to 40%. Let's see how it goes with Abe. And the result of shot is yet another miss. So we blow by the if statement. And we set the shot number, it's now 4. We're still dueling, so we're going to enter. Abe to shoot's going to be false this time. The hit probability goes to 60%. Bo's about to shoot. And he hits Abe. Look at that. Result of shot is hit. So now when we get to the if statement on our line 20, result of shot will equal hit. And so we are going to record the results of the duel. Abe to shoot is false. So Abe did not win. He got hit. So Abe wins in the ith place, the first place of the Abe wins vector, is going to become a false. And sure enough, here it is false. We update the shot number because that sits at the end of the loop. But that won't matter for us because we're not going to get back into that loop again. Dueling became false when we entered that if statement. So we'll blow out of the while loop. And we went to the bottom of the for loop. And now the I index is 2, the final value in our iterator. Dueling is now back to true. Shot number being set to 1. And we're going to play our duel again. Okay, so Abe is to shoot. 40% hit probability. Result of shot is a miss. Update the shot number. Get back. We're still dueling. Bo is to shoot now. Hit probability is at 60%. Result of shot is another miss. So we're just going to update the shot number. Still dueling. Abe is to shoot. This is shot number 3. Hit probability is down to 40% again. Result of the shot is a hit. Okay, so we get into the if body of the if statement. This time, we're on shot number 3. Abe was to shoot. And so the if-else statement makes it true that Abe wins. And so we see in Abe wins in our runtime environment that the second element is true. Out of the if statement, we update the shot number spuriously, but we're not going to be getting back into the while loop because we set dueling to be false. So we are now out of the for loop. We have our results. We just need to count up how many times Abe won and divide by how many times we simulated, which was reps. That's the final expression that's going to be run. So it should be what's returned by this function. Here we go. Out of the debug situation, Abe won 1 out of 2 times, and so our pitiful estimate of his winning probability is 50%. Very well. I'm going to undebug Duel, and I'm just going to give it a try now with more reps. How about 20,000 reps? And I won't bother to set a seed. Rather quickly, the work is done, and I see in my console that Abe won 52.8% of the time. So I'm guessing that his winning probability is around that percentage, a little bit over 50%. So he actually has a slight advantage, even though he's a weaker shooter, and that's because he goes first. Okay, make a careful study of the logic behind this function. Run it in debug mode yourself. Understand how the state of the duel is being modified appropriately with each step of the duel. Understand how at the end of the duel the results are being recorded, and how the for loop controls doing a complete duel once each time through. Thank you. See you next time with more examples.